All right, welcome to our office hour. And tonight we are going to go over our topic is just challenging problems in general. So let's take a look at number one. And here we have a problem where it typically the issue is if you look at we should know that the tangent is the opposite over the adjacent, and BAE is this angle. Now the mistake that we usually make is that since it's the opposite over the adjacent, then we make the one the opposite and the four the adjacent. But that's a problem because we don't know that it was one and four. We just know it was a fraction that was reduced to one fourth. So the way that we want to look at, I will write one and four, but we are going to have to amend that. And I'll show you why in a second. Because then if we do the tangent of CDE, that's this angle, is 2/5. Well, we can't do, again, that doesn't mean that it was 2/5. It means that it was something that had a ratio of 2/5. So it reduced to 2/5. So the thing is, if this is a rectangle, you can't have this side be five and this side be four. So that just doesn't work. But what you can do is you can think about it like this. Well, we need these two sides to be the same because it's a rectangle. So then what number does both four and five go into? And that's 20. So this means that this would be five because 5/20 would be one fourth. And this would have to be eight, right? Because 5 times 4 is 20. So 2 times 4 is 8. That would work. Now we have 8/20 that reduces to 2/5 and 5/20 that reduces to one fourth. And then we can actually say that that's the length of BE and EC, which is 5/8, which is answer choice B. Okay, so the key takeaway there is in these problems, don't necessarily make it equal to those values. Just understand that can work for some problems, but just be on the lookout for the times where it could be something like an unsimplified fraction that would reduce to that. All right, number two. So in the equation above, if f of 2 equals 3, what is the positive value of g of 2? This one looks confusing, but this represents a coordinate pair. This is 2 comma 3. When I plug in 2, I get 3. Anytime in the SAT you're given a coordinate pair or something like this, just plug it in to get started. So that means 3 goes over here. And I'm replacing each x with 2. So I have g of 2 squared minus 7 times g of 2 minus 15. And they want the value of g of 2. Well, let's just to make it a little easier, let's just replace g of 2 with something else. All right. So I'm not going to use x because we already used x up here. I'm going to use y. So this is like y squared minus 7y minus 15. This is something that should look much more familiar. So the idea is they just want to know what g of 2 is. So just think of that as a variable. And that means I just bring everything to one side and then factor. So I'll go up here. So that means 0 is y minus 9, y plus 2. So we get two answers, which is 9 and negative 2 if we set each of these factors equal to 0. But they want the positive value, so it's got to be 9. All right. Moving on to our next one. Okay, so the given equation has exactly one distinct solution. What is the equivalent expression to j to the 2m minus n? All right, so first of all, if you have this one is very complicated, but we need cues to help us get started. So the cue here is if you're talking about the types of solutions to a quadratic, it is going to be the discriminant b squared minus 4ac. And if it has exactly one solution, that's going to equal 0. So b squared is b is this 3j to the m. minus 4, A is 1, and C is 40J to the N. All right, so if I square this, 3 squared is 9. J to the M squared, when you raise a power to a power, you multiply. So that's M times 2, which is 2M. And this is 160J to the N. All right, now we want J to the 2M minus N. Well, the reason that I would be subtracting exponents is because I would, that's through the division property of exponents. All right, so I'm going to do this. Add the 160J to the N to the other side. And then I'm going to divide by 9 and divide by J to the N. Because J to the 2M over J to the N, that's where you subtract your exponent. So that's J to the 2M minus N. That is the exact thing that we're looking for. That's just 160 over 9, which is answer choice C. All right, let's keep moving. All right, so the area of circle A is 18.49 pi, and the area of circle B is 166.41 pi. And the ratio of the radius to A to B is the same as the ratio of B to C. So what we want to do here is figure out the scale factor. Okay, the ratio of the so if we look at it like this, A to B, and then the same ratio from B to C. Well, going from A to B is going to be some scale factor. And then we're going to multiply by that same scale factor to get to C. So the scale factor we typically call K. The scale factor is just what the radius or what any single dimension would be multiplied by to go from the smaller one to the bigger one. Or it could go from bigger to smaller if it's like a number less than 1. But in this case, we're going bigger. All right. Well, what they're giving us is the areas. So every time you are going from one area to the other, that's always the scale factor squared because we're dealing with the second dimension here. So what you need to do is just divide these. And if you divide those, you get 9, which means the scale factor is 3. All right. So if you multiply the area by 9, that means the radius was multiplied by 3. And then if this goes 3, then that's 3. So to go from, so C is how many times larger than A? Well, if you have to multiply by 3 to go from A to B and 3 to go from B to C, you're going to multiply by a total of 9 to go from A to C. Okay, let's keep going here. Let's take a look at number 5. So we have the triangle ABC is similar to DEF, the ratio of the area. So we got another one where we're talking about the ratio of the area. So ABC, if we think about it, is going to triangle DEF. Right, this one's a little tricky because it's 4 to 9. But what I want you to think about is the area. If the ratio is from 4 going from 4 to 9, all right. What that means is we're multiplying the smaller area by 9 over 4 to get to the bigger area. Okay. See, if it were a ratio of like, I don't know, 1 to 2, you would know right away that we're multiplying by 2. Well, we could do the same thing here. If it's 4 to 9, we could divide each side by 4, right? Because a ratio is kind of just like a fraction, so you can divide, it's like dividing top and bottom. That gives you the ratio 1 to 9 to 4. 1 to 9 over 4. So therefore, 9 over 4 is the thing that the area is being multiplied by. Okay? Well, now let's find the area of ABC. Triangle ABC has base x and height x. The area of a triangle is 1/2 base times height. Well, 1/2 x times x is 1/2 x squared. And then if that gets multiplied by 9/4, that's going to be 9/4 times 1/2 x squared, which is really 9/8 x squared. And they want the area of triangle DEF to be kx squared. Well, therefore, k has to be 9/8. All right. Let's keep moving. So number 6, we got a quadratic function could be used to model this. And this is projectile motion. So, we have something like this. And it says, according to the model, the rocket was launched into the air from a height of 4 feet, and it reached its maximum height of 184 feet at 6 seconds. So that tells us that the vertex up here, the max height, is 6 comma 184. What's the height after 5 feet? So when they give you the vertex, you want to use vertex form. So vertex form is y equals a times x minus h squared plus k. And then they're telling us h and k are the vertex. So what we know now is it's y equals a times x minus 6 squared plus 184. All right, so projectile motion problems, you're going to want to use vertex form. Now I want to solve for A. So in order to solve for A, they're going to give you some other information or another point. Well, they're saying it was launched from a height of 4 feet. So that's the initial value. So that means the height is 4 feet when x is 0. All right, so we just have to solve this. So I can subtract 184, so I'll get negative 180. And this is negative 6 squared is 36, so that's 36a. And if I divide each side by 36, we should get a is negative 5. So therefore, our equation is y equals negative 5 times x minus 6 squared plus 184. And then it wants to know what is its height 5 seconds after launch. So you're just going to plug in 5 for x. Well, 5 minus 6 is negative 1 squared is 1. So you end up just getting negative 5 plus 184 is 179. All right. Let's keep it moving. Okay, so number 7, we got two exponential functions. All right, this one seems much more challenging than it is. Just looking at the answers, it looks like it could be confusing, and there's a lot of constants and variables here. But all we know is they have the same y-intercept. Well, y-intercepts are when you replace x with 0. Well, if I replace this x with 0, b to the 0 is 1. I'm just going to get a plus c. And if I replace this x with 0, again, b to the 0 is 1. I'm going to just get p plus q. And they tell us that these y-intercepts should be equal to each other. So that just gives you d. So again, if you just read it and try to reason your way through these, it's very difficult. You got to have these cues. So earlier we talked about when they give you a point, plug it in. Here, when they're talking about y-intercepts, just make x 0. And then they're telling you these y-intercepts are equal. So you just make x 0 in each of them and set them equal to each other, and you land right at the answer. All right, number 8. So here, for a given function, the value of f of x increases by a certain percentage each time x is increased by 9. So what you can do here is pick two values of x. All right, x equals 0 and x equals 9. Because that's an easy way to see. 0 is always easy to plug in. And we want to see what happens when it's increased by 9. Well, when I plug in 0, 1.4 to the 0 is 1. You just get 18. Now, when I plug in 9, I wouldn't figure out the whole thing in a calculator. What I would do is leave the 18 there. When I plug in 9, 9 over 4.5 is 2. I would just do 1.4 squared, and that is 1.96. So what's happening is when I increase by 9, by what percentage am I increasing? Well, I'm taking 18 and I'm multiplying by 1.96. We should know that 1.96, that represents a 96% increase. So we have to be able to, so when we take away 1 from the number that we're multiplying by, what's left is the percent increase. So if I take away 1, I'm left with 0.96. That is a 96% increase. All right. So, a similar type of problem, percent increase for this one as well. So the number of laptops sold in 2019 was 150% greater than 2018, and the number of laptops sold in 2020 was 35% greater than 2019. Which of the following is the number of laptops sold in 2020? And we start with K. So the idea is this: if you're increasing something, I'm actually going to do this one first. So the reality is, whatever I multiply to go from 2018 to 2019, I'll put that here, and then the next one will be the next year. But I'm going to do this one first. The reality is, it doesn't matter what order because I'm multiplying anyway. But I'll put it here because no one really makes a mistake on this one. If something's 35% greater, just like the last problem, we're working the other way here. If something's 35% greater, that's going to be 1.35. It seems like when we do something more than 100%, that's where I see the mistakes. A lot of people would put 1.5. But let's go back to this one. What we're doing is we're thinking of it as 35% greater, and the baseline here is 100%. If you keep it at 100%, you don't change it. So if I'm doing 35% greater, that's like 135%. And if I change that to decimal form, that's 1.35. Or you could change it to decimal form first and then add 1 to it. Well, if I do that here, 150% plus 100% really means 250%, which is 2.5. Or you could think of it 150% as a decimal is 1.5, and you have to add 1 to that for the percent increase. So that is either way, you get 2.5. And again, mine are out of order, but that doesn't really matter because multiplication is commutative. Either way, we get answer choice B. All right. So again, the common missed answer here, the wrong answer is A, because we see 150% and we do 1.5. But we have to remember, no matter what, after you change it to decimal form, you add 1 or add 100% and then change it to decimal form. Either way works. Okay. Number 10. Number 10 is a common problem. Just it's not too difficult once you know how to look at it appropriately. So the diameter is 26. So that tells me C to D is 26. But I'm not going to look at it that way. And it tells me AB is 24. So here's how I want to look at it. If the diameter is 26, then that means the radius is 13. All right. And the radius being 13, I can draw the radius any way I want. So looking at OD or OC, OC will be helpful eventually because I need CE. So remember that OC is 13. But what I want to do is I want to do it like this. I want to draw that as the radius. All radii are equal. So that's 13. And the reason that's helpful is because if AB is 24, then EB is going to be 12. Now, we should all know our 5, 12, 13 triangles. That's a Pythagorean triple. So that means this is 5. And now I go back to the radius is 13. So this is 13. And if I just want CE, I'm just subtracting them. So the answer is 8. All right. So it seems like really easy when I do it. But so you have to look at it as these circle problems. Most circle problems, find the radius is like the key to the problem. And then it's about drawing in the radius in a way that's going to be most helpful. You could have drawn it from A to O, and I could have just done the same problem on the other side. that would work, obviously, as well. Okay, so let us keep moving to our last two problems of the night. And we have two different inlet pipes. And pipe A can fill in 4 hours and pipe B can fill in 6 hours. If both pipes are open simultaneously, how many hours will it take to fill the tank completely? Okay, so there's a formula for this, but I wouldn't memorize it. I would try to like really understand how to do this problem, and then you'll be more likely to remember it if you have to do a problem like this. So the way I want to think about this is if it takes pipe A to fill it on its own in 4 hours, what I really want to think about is during that first hour, what fraction of it will be filled. All right. So if it takes 4 hours to fill the whole thing, then in the first hour, it's going to be 1/4 filled. Then pipe B, well, that takes 6 hours to fill. So when it's on its own, it takes 6 hours. So that means during the first hour, it should be 1/6 of the way filled. Now, what happens is when they're now working together during that first hour, the amount or the fraction that's filled is adding these together. Because now that first hour, this one's doing a quarter of it and this one's doing a sixth of it. So that adding those together tells us the fraction that's filled during the first hour. So that's the key to the problem, is just looking at it as just the first hour. So I'm just going to add these together by getting a common denominator. So I'll make these both 12. So this is 4 times 3, so that's 3/12 and 2/12. So that means 5/12 are filled in the first hour. Now, I want to change this. Let's pretend, just to make up something, let's pretend that it was 1/3 full after the first hour. I think we could all see that that means it would take 3 hours to fill it up. Or if it were 1/5 full after the first hour, it would take 5 hours to fill it up, right? So it's pretty easy to imagine that when the numerator is 1, but all we're really doing is we're taking the reciprocal. So if it's 5/12 full the first hour, the amount of time it's going to take to completely fill up is going to be just the reciprocal of that. So it's going to be just 12 divided. So you're going to flip it, and it's going to take 12 over 5 hours to fill up. And 12 divided by 5 is 2.4. Okay, let's move on to our last problem. And number 12, if the given equation K is a constant, the equation has exactly one real solution. Which of the following could be the value of K? All right, so a couple things here. If you were to solve this, you would set each of these equal to 0. Right? Because we're using the zero product property. This is already factored for us, so each factor has to equal 0. Well, this gives us x equals 5. Well, it says there's exactly one real solution. Well, that's it. That's our real solution. So that tells us that this should have no real solution because we already have our real solution. Well, now we're just as I mentioned earlier, you have Q's. The Q here is types of solutions of a quadratic, automatically the discriminant. You could also use Desmos here, but I'm just going to do the discriminant because then Desmos, we'd have to check all the answers, which again is not really that big of a deal. But I still think the discriminant might be faster. So if I want no real solution, I want the discriminant, b squared minus 4ac. I want that to be less than 0 because remember, the discriminant is under the radical. And if the radical, you can't take the square root of a negative, that's what would lead to no real solution. So b squared is 16 minus 4 times a is 1, c is k. And what I could do is I think I would just stop here and realize that 5 has to be the answer because 16 minus 4 times 5 is negative, and all the other ones give me a positive. So that's how I would do it. I wouldn't even waste your time rearranging that. All right. Again, you could throw this into Desmos and use a slider and then just make slider all these values and see that 5 is the one that will make the parabola not cross the x-axis. So totally, that's a good way to do it. But I just wanted to go over the discriminant again here. All right. All right. That is going to be the end of our office hour. So again, make sure you check us out on TikTok or YouTube. I will upload this whole session. I'll splice it up and put a bunch on TikTok, and I'll upload all of it to YouTube for those that weren't able to come here. We offer one-on-one math tutoring and an SAT math prep course. So please make sure you check that out.